Hello and welcome to the latest webinar by Bic Gardner. My name is John Kowalski here from marketing. I'd like to welcome you. If you're unfamiliar with our office hours format, it is a shortened presentation, usually 20-25 minutes, and then the floor is yours for questions, answers, discussion. So if at any time you have anything going on at one of your facilities or anything we can help with, just drop it in the chat. That should be in the bottom right-hand corner of your screen, and we'll get to that and make sure all your questions are answered. We are also recording this, so after the webinar, you'll receive an automatic link to that recording. Feel free to check it out later, grab some screenshots, share it with colleagues, whatever you like. Today's topic is color measurement tools and uses. We have Mr. Noah Morgan, one of our application specialists, presenting. Noah, how are you, sir?
Good, thank you. Yeah, so like John mentioned, today we'll be going over color measurement tools and uses, specifically getting into our product line of Spectra Photometers, where each one will excel in each different geometry, and we'll be going over our multi-angle instruments as well and the differerences between what they measure.
Sounds like a plan.
Yeah, be a
nice. Take it away.
Nice presentation. So we'll get into it. Starting with our Spectra 2 guide. So this is one of our handheld Spectra photometers. It comes in two different types of geometries. So the D8, also known as the sphere geometry, that one includes two different measuring types. So you have the specular included and the specular excluded. So two different types of measurement geometries inside. And then we have the 45-0. So that instrument's going to measure how our eyes perceive color. So in that 45-0 geometry. And with these instruments, you also have a 60-degree glossimeter built into them. So they'll take color measurements as well as gloss measurements. So you'll get a full visual analysis of what you're seeing with the spectrophotometer. So getting into gloss and the main differences that you'll see between those two different geometries is usually in reference to how that surface texture is. So to get into what all we're talking about, we first have to see what is gloss and how is gloss perceived. So gloss is just when any incident light, and here we have the sun comes down to a surface, reflects off the surface, that is our gloss. So that's going to reflect incident light. And when that happens, typically on a glossy surface, you're going to see all of that light coming at the opposite angle. And when we go to look at the surface itself, we're going to see a very clear representation of what that reflected image is. So they have very good mirror forming qualities. And so in this example here, we have this plus sign. And with the glossy sample, that plus sign is going to be very, very visible. It's going to be crystal clear. But if we switch over to a matte sample, now it's going to be very blurry. And it's blurry because all of the microtexture in that surface is going to scatter the light and then create this image that we see. And so now in our representation of a gloss image, we have our light coming down. And as it hits the surface, those microtextures, again, they scatter. And then now we have light going in different directions. With the main still coming back towards our eye, but we're still losing a lot of that main gloss. So where does this come into play? So right here we have two different samples. We have a black sample and a red sample. And with each of these samples, we have one side that's glossy and one side that's matte. So it's two different surface preparations. And when we look at them themselves, we see that the glossy sides are usually more vibrant. They give us a deeper color, a darker color in some cases. And on the lighter side, or on the matte side, we see lighter differences. So it's a lot lighter. It's not as deep as a color, not as chromatic. It's more of a pastel. It gives us a dull feeling. And so what we're seeing here is that the gloss has a big influence on what we see the color as. And so now when we go back to our main graph and our black sample, when we look at the glossy side, we need to perceive color in a specific way, and that's done through the 45-0 geometry. And so that's what one of our instruments measure as, and that's the typical geometry geometry for visual color analysis, which basically has a light source coming from a 45-degree angle and then an observer directly overhead at 0 degrees. It could be switched around where you have a light at 0 degrees and then you observe a sample at 45 degrees, and that's like the case of using a light booth. But this is the typical internal geometries for an instrument. Now, when we look at the matte side, that matte surface, we again have all that light scattering, and so now it's going to create this diffused look, and in turn change how that measurement is going to take place with a 45-0 geometry. So we see a clear difference in what that color looks like to us based on that surface texture. And that's the big difference with the 45-0 geometries, because that's going to measure that difference. Whereas the sphere geometry is designed in a way to where it doesn't measure that difference. And we'll talk about that later on. So here we have the internal equipment for what's going on inside of a spectrophotometer. And this is specifically for the 45-0 type geometry. And so, again, this measures how we see color. So we have a light source coming in from 45 degrees, just like that other example. And then we have a detector directly overhead at 0 degrees. With this, we have circumferential illumination. So our light's coming from all sides. So what that's useful for is no matter what orientation you have the spectrophotometer, you're still going to get the same color measurements. With this geometry, again, this is going to measure those differences that we see. And so it's going to take into account the gloss and the surface structure, and then put that into the metrics that determine the color differences. So we're going to get a full representation of what those color differences are versus what we'll see next in the other type of system. What the 45-0 is good for is for comparisons to defined standards. So if you have color or target colors that you need to achieve, those target colors usually are for products that have an end appearance. And with that, you'll use a 45-0 to measure those differences. Also good for batch-to-batch control or quality control, and then harmonization of different materials. So, let's say if we have a refrigerator, we want the side panels to match the front panels and the back panels and the handles. So we're going to use a 45-0 geometry to record those differences and make sure everything is exactly the same. And then again, the circumferential aspect of it, unlike a linear light source, we're going to get differences where no matter the orientation with a linear setup, you're going to get differences. But if you have a circumferential light source, it's not going to take into account those differences because it's getting the same measurement no matter how you hold it. Now going into the sphere or the D8 geometries, starting with specular included. So this is the original development of this type of equipment. And what this is useful for is it's for color matching, where you're just worried about the pigmentation differences, for, let's say, weathering studies. Also color strength development, because it's not taking into account the surface structure. And we see when we look at how it's taken the measurement, we see it uses a very different setup. Now we have the light source that comes in from the side. And what that's doing is it's creating a diffused illumination rather than the 45-0, which uses a direct illumination. And when it does this, it now diffuses the light through the sphere. And this is a white coated sphere. And it reflects all around until it eventually reflects off the surface of the sample. That spectral reflectance then gets scattered back into the sphere until it eventually hits this detector at 8 degrees. And that's where the D8 value comes from. So with this, we're not going to get those differences in the gloss and structure. It's not going to take into account that information. So we're just going to strictly get our color differences, our absolute color differences, purely on the pigmentation. And with this sphere geometry, there's also another way where you can simulate values that would correlate better to what we see visually, rather than just having the pure pigmentation change. And so with that, there's a mode called specs, or specular excluded. Sometimes people write it as SCE. With this geometry, this opens up a gloss trap. And so now as the light scatters, that gloss information gets sent back to our gloss trap, so it captures that gloss data. And so now you can take into account the gloss and surface structure into the color measurement, and get a similar set of values that correlate to your visual representation. So you can use the instrument for two purposes, let's say. What's nice is that it does correlate in certain situations. So in high gloss surfaces, you will get a good correlation. But as you go lower and lower in gloss values, you're not, as that light diffuses more off the surface, you're not going to get all of that data back to the sensor. And therefore, your correlation is going to diminish as you get lower and lower in gloss. So now let's look at some studies between the three different types of instruments. So the 45 0, the D8 specs, and the D8 spin. So again, the specular excluded, that has the gloss trap. So it's designed to also capture the gloss data. So when we look at the blue graph, so which is the black glossy sample up here in the corner, when we look at the blue graphs, 45 0 and the D8 specular excluded, they match fairly one for one. So our blue lines are almost identical on L, A, and B axes. And when we look at the matte sample, the orange graph here, now we start to see differences. Remember, as we get lower and lower in gloss levels, our correlation diminishes. So now we're getting a lot higher values on the L axis, and our B value remains the same. When we look at the 45 0 compared to the spin geometry, specular included, which doesn't take into account the surface structure, we see major differences. So again, we see this instrument just measuring these two sides as the pigmentation. It's not taking into account what our surface texture looks like. And so when it takes these measurements, it's saying these two samples are exactly the same because it's the same material. But in reality, we see these as different, and that's where the 45 0 comes into play. And with the D8 specs, you can somewhat get there, but it doesn't correlate as much as we get lower in our gloss level. So changing colors here, now we have a red sample, so we see a little more action in the A and the B values. When we look at this, again, the 45 0 correlates fairly well to the D8 specs as far as the blue sample, the glossy samples. And when we look at the matte samples, they're still fairly close to one another. Small differences in the LA and the B, but they're still fairly close. But then when we look at the D8 spin, now we see again, both samples are exactly the same, or both sides. And it doesn't correlate to either of the instruments or either of the other geometries. So you can see that in some cases, it's better to use the 45 0. Based on the data, it's going to better match what we're truly seeing. But let's say if we were making injection molds and we wanted to test the raw material coming in, we would want to just measure what that raw material is, regardless of what that surface texture looks like, what the gloss level is. We're going to want to use a spin instrument because we want to capture how that raw material is in the pure color form of it. And so those were basically our three different types of geometries for spectrophotometers, not including the multi-angle. But now we're going to go into some special applications, which is where you can really start to see where some instruments might be better, where some geometries might really excel, just based on their capabilities. So right now we're getting into jetness. On the screen you see some samples here. So these are jet black samples. And what's special about jet black samples is that they have little to no reflectance, meaning when light shines on the surface, the spectrophotometers work by measuring the reflected light off of that surface and then putting those into color values. And what happens with the black is that there's inherently so much absorption of light that there's almost zero reflectance data, and therefore you have zero data to create color values off of. And in here, what we see is that these range from a brownish undertone to a bluish undertone, from left to right. So we clearly can see some differences in the shades of these, but in some cases, spectrophotometers just can't measure them because they're so low in reflectance values to begin with. And so with that, again, what is black? Is black truly a color? When we look at the definition of black, it is the result of an absence or the complete absorption of visible light. So black means that there's no light. And when you have an instrument that measures light and then puts it into these LAB values, you have to ask the question, are LAB values suitable? Because at certain points, we can measure all of those original black samples. We can measure all of these, but all of our LA and B values are going to be identical, which is no good if we're trying to describe them numerically. And so with that, new indices were developed. So we have special indices called the Jetness indices. They originate from the XYZ values, and they're put through some different functions to really capture different aspects of what we're seeing. So one is the blackness MY, and this is your hue independent black value. So this is going to measure black strictly in regards to black. Then you have the Jetness MC value, so your color dependent black value. So this is your black value, but looking at the undertone, whether it's that brownish undertone or that bluish undertone. So it's a very nice scale to go off of as well. And then lastly, you have the undertone DM, which looks at the pure contribution of what that undertone is. So again, we have our blackness MY, which is basically how black of a sample this is. Your Jetness MC value, which looks at the black taking into account the undertone. And then we have our undertone, which looks at our pure contribution of the undertone towards that color. So in addition to those new indices, we have another problem that occurs is instrument noise and electronical noise. And that's inherently with every type of electronics that are developed and made and used, is you're going to have some type of electrical noise. And the problem with color measurement, especially with these deep blacks, is that once you get so deep into zero reflectance, you can see this. This is a spectral reflectance curve looking at the light energy that gets reflected off of a surface. And we're so low, we're at a 0.1 as far as reflectance, which is very low. Normally we're, whites go up to 100 and over and beyond. And so when we're looking at this, it's very low, and we start to have electrical noise affect that value, but what it's actually reading. So in that case, new innovations had to take place. And that's where this instrument comes, the Spectra 2 Guide Pro. This instrument was a result of this theory of diving into measuring these deep blacks. And with that, we created this Jetness mode, which is improved based on some production processes that had to take place and some special calibration processes. We also changed some of the electronical components internally. So there's special LEDs in there, as well as a special sensor that lets it see deeper into what these blacks are. Some of the adaptations that we had to take place, we amplified the signal. So the LEDs were basically powered stronger and for a longer duration, so you can get more data from that deep black. And then some of these electrical components internally also resulted in less instrument noise. So that also amplified the signal. And so when we look at a graph of some repeatability studies that were done based on these deep blacks, we took the deepest black, which had an MY value of 393, which is very deep. When we look at that color, it almost looks like a black hole. There's no reflectance coming off of it. When we measured it 50 times in immediate succession, so this is for repeatability, we found that the standard deviation was a 0.0002, which is very, very low. When you look at the graph, it looks very jumpy, but it's actually zoomed in very, it's got a high zoom on it so that you can see the deviation themselves. But with that standard deviation, we were pretty successful and excited based on that discovery that we're able to get pretty good repeatable measurements on these deep blacks. And using those jetness indices, you're able to then quantify what those differences are, which hasn't been done before in the industry, which was nice. So again, the Spectra 2 Guide Pro, the ultimate way to measure black with adapted production processes. I mentioned we changed a lot of the electrical components so that lowered what that electrical noise could do. And then we improved the jetness mode with these higher powered LEDs that are extended longer. And then even the calibration process changed with a new test on dark gray instead of a white. And what that's able to do is lower the reflectance values that it's calibrating at, so it can really get deeper into those deep blacks. So now switching gears a little bit, we're going to go into another, let's say, special application with effect coatings. We have sparkle and sometimes graininess on these special effect coatings, as well as color flop and light and dark flop. So here we have some examples of that. We have a silver car here that is showing a light dark flop, where essentially as we go through the contours of that color, it's the same color that's applied to it. But visually it'll go from a dark to a light just based on how those pigments are flopping. And then below that we see a pearlescent coating, and there we see a full color flop. So as we go through those contours with our eyes, we see it goes almost from a blue to a purple to a green. So a very major color flop there. And then lastly, we have some special effects like glitter and sparkle. And those are made from different types of additives to the formulation. But what we're trying to do here, our eventual goal, is to be able to measure what's going on, because if we use conventional means like the ones we went over, we're just going to measure one angle. But obviously in these cases, we have differences in color and some other special effects taking place at multiple angles. And so for that, we're going to switch instruments here and go into our multi-angle instrument. So looking at a spectral reflectance curve, which is thought of as the fingerprint of a color, we see that with a typical solid green color, we're going to get fairly close values across all the angles because not much is changing. The solid green or solid color, it's going to be the same no matter what angle you're looking at. So you expect to see all of your curves just right on top of each other. But when we get into a metallic green or any type of metallic color, now we're going to see a flop. So as we change our viewing angle from 15 degrees to 25 to 45, 75, and 110, it's going to go from that very light gray or light green to a darker green to a darker and to eventually a very dark green, almost black. And so we're seeing a color flop and a color difference here. Now when we look at metallic silver, this is usually where you have the most extreme examples of, as we go through our contours, again, you have from almost a pure white color, like we see here on this line, and it gets darker and darker and eventually almost a pure black. So it's very hard to sometimes characterize silvers and get them right every time, just because of this extreme light dark flop that they have. And so obviously with these graphs here, we see that now there's a need to also measure color at multiple angles. So that's where the BYK-mac eye comes in, and this instrument can measure color at those multiple angles, but it also has the ability for flake characterization. What we mean by that is sparkle and also a graininess effect. So again, the instrument measures color by illuminating at 45 degrees. It's kind of the standard. And then it has detection angles. So your spectrophotometer is at negative 15 degrees. That's for your color flop. 15 degrees, 25, 45, 75, and then 110 to give you a full encompassing effect. And then for sparkle, there's a direct illumination at 15 degrees, 75, and 45. The reason for that is because, let's say, if you're outside on a sunny day, you can see sparkle. So that's why you need direct light for sparkle. But if it was a cloudy day is very similar to diffused light. And when you look at sparkle under diffused light, that's where you get this image of graininess. It doesn't look as bright and vibrant, but it has this salt and pepper or this grainy like look to it. And that's where the graininess characterization comes in, where it uses purely just diffused light, and it takes a measurement of how grainy that surface is. And so that way, when you're taking measurements of products, you can get not only our color, so is our color changing, let's say if we're matching panels, is our color changing at each angle exactly the same? Is our sparkle changing at each angle exactly the same? And is our graininess changing at each angle the same? And if all that's true, then both of those panels will match exactly. But if even one of those is true, then you'll have a mismatch. And sometimes it can be very tricky to figure out where the mismatch is occurring. And with the sparkle characterization, you're able to track specifically what angles you're seeing these differences in. And that can play a role majorly into, let's say data analysis, where a lot of times the sparkle at 75 degrees will have a strong correlation to errors in the application process. But also you'll see that sparkle at 15 degrees will show a very strong correlation to errors in the paint formulation, just based on how those flakes are laying on the surface. So you can use the tool in a lot of different ways, and one of the most valuable one is the data analysis portion, just so that you can figure out where problems are occurring and why they are occurring. But with that is essentially it. So now we'll just open it up to questions.
Nice, Noah. Thank you. And I like the fact you ended on the data analysis, because that is so important, and I think it's just not used to the full potential. With different customers, because it can really get into those intricacies of what's going on, and to make sure you're optimized and make sure you're getting the color that you're specifying kind of on the front end of the process.
Yeah, absolutely.
So good stuff. Questions out there, if anyone has any questions, please log them in the chat box and we'll get to them. One of the questions here is about liquid. Can these instruments, these tools, measure liquid color?
Yes, great question. So we do have a dedicated instrument for measuring liquid color. It does it by sending light through, let's say, a vial of liquid, and then it measures the reflectance based on that. So that's one method of measuring color. There's another one. We have a benchtop version of the 45-0, which measures color how our eyes perceive it.
Yeah.
And that instrument, it's possible to use a clear cup and measure sample essentially with it being on the top of an aperture rather than being on the bottom of an aperture. So two different options. One of them is an LCS, and we can get with you privately after the webinar and just maybe set up a time to talk with different applications with you.
Okay, good. I'll let them know. And you mentioned apertures too, and like specifically on the Spectra 2 guide, are they interchangeable?
Yeah, so on the handheld units, they're not interchangeable, but there are two different models that we're selling. One of them has a smaller aperture, around 5 millimeters, and the other one is about an inch, maybe let's say 3/4 of an inch.
Okay, and those are the bench tops, yeah?
Those are the handhelds. The bench top has multiple apertures that you can change. So you can get one basic model, and then you have three, let's say, other apertures that you can interchange with. Perfect. So there's a 4 millimeter, a 12 millimeter, and then I believe a 32 millimeter. So
Okay.
that'll cover large
Yeah.
to very small.
Yeah. Awesome. Okay. For injection molding applications, what do you recommend in terms of the equipment, whether it's the 45-0 or this D8?
Yeah, for injection molding, that would be where I would recommend something like the D8. That way
Okay.
you can measure let's say your raw material coming in, where it's going to have different surface textures. That's just based on the finishing. And if you want to measure if there's anything changing with your raw material, the D8 is where that's going to play a role. But if you're going to start measuring stuff where it's, your end user is going to see it in that form, and you want to match things in that way, that's where the 45-0 would be recommended.
Okay, good. Thanks for clarifying that. Another question here from Peter. For measuring grays or whites, am I better off using a BYK-mac or a Spectra 2 guide or something else?
Yeah, good question.
Yeah.
For measuring whites, all the instruments can do it. If it's a white let's say it's a metallic white, then a BYK-mac is going to be better because the metallic flake is going to change the color or change the lightness at different angles. And you want to be able to characterize that. But if it's just a solid white, then you should be fine with a Spectra 2 guide.
Okay.
But all of the spectrophotometers are going to measure pretty much the same, no matter what color it is. So you should be all set.
Excellent. Can you talk a bit about digital standards and how they relate to color harmony?
Yes. So digital standards are very nice. That's something we've been able to implement with our software Smart Chart.
I know this is one of your favorite topics.
Yeah, this is a good one. In the past, a lot of standards of colors were kept on plaques or panels. Where these are physical panels that get sent out to different facilities. With that, you have a lot of effects that could take place, and they could degrade over time. They could get scratched or dirty or misplaced. You have to send them out every year. There's a lot of upkeep to keeping these panels. And with that, when you take a look at color measurements is a very precise type of science. People see it differently, which creates issues. But when you take instrumentation and quantify those values, then you have hard values to go off of and describe things. Where digital standards start to take a major role is that it creates the ability for one lab to create one set of panels. Let's say there would be master panels, and create spectral values based on what those panels are. And those spectral values are literal fingerprints of the color. And so you can then send that out digitally through an email file to multiple facilities at the same time. So now everybody is matching their products on the exact tolerances and the exact color that you have created. When you start to have multiple panels that get passed around or go to different places, if those panels are slightly different, you could have a case where you have 5 panels that you send out to multiple places, and 2 of those panels, one of them, let's say, it's within tolerance, but it's on the low end of your tolerance. It's a little darker, whereas another sample in that batch is maybe slightly higher on the lighter end. And then you send those panels off to different facilities, and they measure them in and create tolerances. Now they have one that's on the high end. They created a tolerance around the high end, and you've created a tolerance around the low end. And so now, let's say further down the line, if we have multiple batches and samples, we start to have failing ones that are on the high end, or we have passing ones that are on the high end, and another facility has passing ones that are on the low end. When they come together, they may not match up correctly. That's some issues that could happen, and that's where the spectrophotometers really play a role in providing the digital standards.
Yeah, and also if the
so it's a lot better system.
Yeah, exactly. And if the physical panels aren't stored properly and in different, it could, cause some fading or, degradation as well. And then that's going to, kind of affect your overall production pieces.
Yeah, for sure.
So interesting. Let's see. Next question here. How do we correlate measurements from Bit Gardner with those of other companies? Or will all the equipment have similar readings?
Yeah, so they'll all have similar readings. Everything is based on usually industry standards.
Yeah.
Usually for color measurement, you're looking at LAB values or XYZ values. But all of those are really based on the spectral reflectance curve. And I keep bringing that up. Basically, the instrument will take many data points over a surface, and that'll quantify color. And then these typical scales that we're used to seeing, like LAB or XYZ, are just broken down versions of all of that data. So if you can imagine, you take, let's say 1,000 data points and then scale it into 3 data points. You're not getting a true representation, but that's the typical standard for how you put value to what those numbers are. Your LAB scale is basically your color coordinates. So they'll match up with other instrumentations and other standards that you're going off of. But the reflectance curve is what you really want as far as the accurate data that it can gather. And that's where the digital standards come in.
Yeah, exactly. And you mentioned, the spectral curves earlier in your presentation. That's the fingerprint of a specific color. I love that term you use. So let's see. Next question here, Samantha. On the Spectra 2 Go, is that good to use for injection molded parts?
Yeah. I'm assuming it might be a 45-0 or a D8, so it depends on what you're using there. But the Spectra 2 Go, I didn't really mention those. That's it's like our base model of the Spectra 2 guide. So same instrument, same capabilities. It comes with a little or some less. It doesn't have all the accessories, but has the same capabilities.
Awesome. I'll throw the link in the chat here if anyone's interested in checking that out here. This is something on the BYK-mac. Can the BYK-mac eye detect particle shape and size during characterization?
So it may not detect particle characterization, but it does have the ability to look at the flake. Specifically, a couple of values that it looks at. Let's say it looks at sparkle intensity. So it'll capture an image over the surface, and then it looks at that image that it captured and sees what points are sparkling. And so you can calculate some values based on that, like sparkle area, intensity, how much of that measurement area is receiving back sparkle information. And then you can characterize it based on looking at the different angles of data sets. And so then you can see how is this sparkle laying in regards to this sparkle. And then we have a software with one of our instruments, the BYK-mac Eye Pro, specifically designed for flake characterization, looking at metallic pigments and how they're laying, which would be good, but I wouldn't say it goes down into the particle size.
Okay. On relates to another question in here. Is there a sparkle angle that would show a formulation issue? Is there a specific angle to look at?
Yes, great question. 15 degrees. So if you're looking at sparkle at 15 degrees, it usually has a strong correlation to errors in the paint formulation. That's because when you're looking at that specific angle, you're seeing the different sizes, and so you can see if there was a different sized flake used, versus what your standard should be.
Okay, cool. That makes sense. Other questions out there, folks, keep them coming. We also have several members from our sales team on. If any of you guys or ladies would like to chime in with some things you're seeing with customers that relate to the topic, color measurement tools and uses, or some specific challenges you've seen, please jump in, unmute yourselves and share them with the group. Noah, are there frequent questions that you get kind of over and over? I know, we always hit on procedure and process and making sure it's apples to apples, from operator to operator, from shift to shift, from plant to plant. But are there other things that you see frequently out there that you're assisting folks with?
Yeah, choosing the right instrument, which is always a good one, and which is nice because that's what this presentation covers.
Mm-hmm.
Usually what's nice with choosing your instrumentation is that you usually have standards set in place, or you're following ASTM or ISO standards, and they usually call out what type of geometry or what type of spectrophotometer is needed depending on what you're doing.
Mm-hmm.
So that's always a good resource to have on deck whenever you're looking for something, or trying to figure out at least where to go and what you'll be measuring. So that's always a good resource. Specifically with some of the instrumentation, I brought up circumferential versus linear. That's a problem I see sometimes, where you'll look at data one way using a BYK-mac, and that's using linear illumination. I'll go back to the slide here. But essentially, you have a singular light source for color coming from one side. And so if I start to change it, especially with different flakes, if I change the orientation of how I'm holding it on the surface, now I'm going to get a completely different set of values. So if you're ever comparing with the BYK-mac, make sure you're taking the measurements in the same way that you took the measurements on the standard, or else sometimes your values won't correlate to one another. You'll have some issues with that.
Yeah, it's got to be, that process has to be locked down. That's for sure.
Right.
Okay.
SOP.
Yeah, exactly. Oh, I just had another question for you and I lost it. Something you said. What was it? It'll come back to me. Oh, now I remember. And like Noah said, if when he was talking about the injection molded parts, if you're unsure what instrumentation, whether it's 045 or the D8 that you need, you can talk to us. We'll evaluate, what you're doing, what you're trying to measure, if there's any standards involved, and we can set you up right. Either Noah, someone on his team, or we have inside and field salespeople all over the place. So someone in your territory can definitely help evaluate what you're currently doing, and if needed, make some little recommendations or adjustments to streamline your process even more. And I know a lot of times, we get in panels from customers. Noah, you can speak better than I on this, but if there's a challenge or something that we're unsure of, send us some samples. Noah or someone on his team will actually do the measurements, look at the data, and tell you what's going on. Did I capture that right, Noah?
Yeah, absolutely. Okay. We have all sorts of samples that come through. So if you ever have anything that you're trying to put numbers to what you're seeing, to develop either a quality control measure or doing some type of research project, we have a lot of instrumentation, and we have a lot of knowledge from people that have lots of experience in different fields. So it's always worth reaching out.
It amazes me how much knowledge is in the organization. I think every month our HR manager sends out everyone's anniversaries, and I think our average tenure is like 22 years of people with the company. It's ridiculous, but that's a lot of knowledge, a lot of smart people. So definitely take advantage of that. Another question too, you talked about, the instruments and measuring both solid and effect colors, but what about texture? when there's a textured part, how does that play in with this instrumentation?
Yes, great question. So with texture, going back to this slide here, with texture, we have the main types. We have glossy, different levels of gloss. Usually it can, matches up with texture. But at a certain point, you start to get, different types of texture. Let's say like leather textures, where now your gloss doesn't really correlate to what you're seeing because you have these big textures. As far as color, you can still quantify the color, but those shaded parts from how tall the structure is going to start playing an effect. But for the most part, the color still works. Color is still a good metric to go off of. But we actually have this other instrument, which is pretty cool, and it measures texture. It's called the Spectra Two Profiler, and it's almost like a 3-in-1. So it'll take measurements of the color, it'll take measurements of the texture, and it'll also take measurements of the gloss, and almost create a 3D topography of what you're looking at a micro scale. And then you can put values on how that texture is behaving, the spacing between we'll call it hills and the valleys, how large those hills and valleys are, how tall they are, the depth of them. And it puts it into numbers to quantify what you're looking at. And then what's nice about quantifying it is now you can put quality control measures in place with tolerances. And so you can essentially research into what you're measuring and then create your process based off of that. But it's a very nice tool for picking up these weird samples or even in the injection molding industry. I know a couple places that use them to figure out, shockingly, how clean their injection molders are. So they'll take measurements of the product, and if the texture starts going down or diminishing, then that usually means in their process that their injection molds are getting dirty. And so that's like a good indicator for them to use in their process. So it's got a variety of different applications.
Yeah, that's a good tool. We have on our website, I just put a link. We have all the product and the usual stuff, but we also have this knowledge library section that is just full of how-tos, a lot of technical white papers. And I just threw in the chat the link to the white paper on 2D, 3D surface texture measurement, where it's getting into the details that Noah just mentioned regarding texture and, building out this topography map essentially of this. So take a look at that if you're interested, or if that's applicable to you. And feel free to kick around in the knowledge library. There's a ton of information, and it seems like every month there's new articles coming out there. So what else? Anybody else have questions out there? Drop them in the chat. We have a couple minutes left here. But if everyone's good, we won't keep you. I know everyone's busy. And Noah's email right there. Feel free to drop him a line after the fact, or if you have any questions that you think of, you get these office hours invites and the marketing messages from us. You can hit reply to any of those. It'll come to my team, and we'll route them to either the territory team in your area or to Noah or whoever's appropriate. And we'll get whatever questions you have answered. Anything else, Noah, from you? Any parting words or advice, tips and tricks?
Tips and tricks. I'll say parting words. If you have any questions about anything, again, appearance related or physical testing related, we're the go-to for information. So feel free to reach out, and we can help you develop something or help you on your path for trying to figure out how to do something.
Yep, absolutely. Oh, it's just curious, looking at the next office hours. We do these on a monthly basis, usually the second Wednesday. Next month, July 9, office hours, measuring texture with the Spectra 2 Profiler. So that's the whole
Ooh,
topic next month. So that ties in perfectly there.
check
Just
that
happened
out.
to be. Yeah, exactly. So you'll all get the invites to that. Also, our YouTube channel, if we keep all the recordings of these, I will drop that in the chat right now. Let me find that. Let's see. There we go. Yeah, so we keep all the recordings of these out on this YouTube channel, so you can check it out and see what we've done in the past. Again, wealth of knowledge, and just contact us if you have any questions. All right, so with that, I think we can all get on with our afternoons here. It's been a pleasure, Noah, as always. Always love chatting with you. And
Yeah.
thank you, everyone, for attending. And we look forward to seeing you on future Bit Gardener office hours. So have a great day.
Yep. Thank you, everyone.